Developing new aptamers to combat antibiotic resistance by screening aptamer libraries and a proof-of-principle microbicidal aptamer that selectively binds to an ampicillin binding protein. In other words, overcoming antibiotic resistance. What's wrong? In 2019, the CDC website stated that antibiotic resistance was associated with nearly 5 million deaths worldwide and directly caused 1.27 million of these deaths, making it a global public health crisis. This is because of the gap between 1987, when the last clinically used class of antibiotics was developed, and today. As a result of this long time period, bacteria was given the chance to further evolve in order to make antibiotics ineffective. Antibiotics work by inhibiting either the peptidoglycan cell wall or the peptidoglycan in both gram-positive and gram-negative bacteria, which would cause a pressure imbalance between the inside and the outside of the cell, resulting in eventual cell death. How do bacteria develop antibiotic resistance? When exposed to low levels of antibiotics for a long period of time, bacteria is able to either change the binding site for the antibiotic or to produce antibiotic-degrading enzymes in order to make the antibiotic ineffective. Our solution. I propose to design an aptamer that will act as an antibiotic without the harmful side effects of antibiotics or the risk of antibiotic resistance. We would do this through aptamer binding. In this image, you can see that yellow is the harmful bacteria, such as E. coli, that has developed resistance to antibiotics, and the blue and orange is the aptamer that would mimic the antibiotic that is currently used to target this bacteria, in this case, ampicillin. In order to select this aptamer, we would use a process called SELEX. So firstly, aptamers are stable DNA or RNA molecules that can bind with high affinity and specificity to targets, such as small molecules, peptides, and in this case, the peptidoglycan of the bacteria. Through SELEX, we would be able to choose the aptamers that are able to bind with PBP, which is the enzyme that is used in the making of peptidoglycan, with high affinity and specificity. By using aptamers instead of antibiotics, we would find both a more time and cost-effective solution that would reduce the risk of antibiotic resistance and the harm that the person taking the antibiotic would have. Thank you.